Let's take a look at approximating the square root of a number that is not a perfect square. To do so, we will use Newton's method. The traditional use of Newton's method is approximating the zeros of a function. However, with a little thought, it can also be used to approximate the square root of a number. We'll see how this works by approximating the square root of 7. The first step is to write a function that has a 0 at 7. The simplest such function is x squared minus 7, which has zeros at positive and negative square root of 7. The general formula for Newton's method is xn equals xn minus 1 minus f of xn minus 1 over the derivative of f at xn minus 1 for n greater than or equal to 1. So we need to find the derivative of f of x. The derivative of x squared minus 7 is 2x. Substitute f of x and f prime of x into the equation. Now, we combine like terms. When we factor out 1/2, we have xn equals 1/2 times the quantity xn minus 1 plus 7 over xn minus 1. Now we choose a value for x0 that is close to the square root of 7. For this example, we'll just use 7. Substitute x0 into the general equation to find x1. x1 equals 1/2 times the quantity 7 plus 7/7. Simplifying this shows x1 equals 4. We find x2 the same way. Substituting 4 into the general equation gives 1/2 times the quantity 4 plus 7/4. This is equal to 2.875. Continuing the same process, let's find a few more terms until the approximation doesn't change. x3 is equal to 1/2 times the quantity 2.875 plus 7 over 2.875. This is approximately equal to 2.654891304. Plugging this back into the equation, we get x4 is about 2.645767044. Continuing on, we see that x5 and x6 are identical to 9 decimal places. This should be a good approximation for the square root of 7. Using a calculator, we find that the square root of 7 is equal to x5 and x6 to at least 9 decimal places.